How's it going, class? In this lecture video, we're going to be talking about different kinds of factoring techniques. Over the course of this semester, we're going to be learning four total factoring techniques. So this video is just going to touch on the first two. The first technique is called factoring out the greatest common factor, and the second technique is called factoring by grouping. Okay. But before we really dive into it, we do need to understand what is the greatest common factor and then what is factoring so that we can, when we look at an algebraic expression or a polynomial, we can factor something out of it, okay? So let's turn our attention now to this document camera over here. I have some example problems that we're going to go through to see if we can get this point across. All right. So first, we need to understand the definition of the greatest common factor. And the greatest common factor is the largest algebraic expression that divides two or more terms. Okay? So that might seem a little bit confusing, especially since we're using this fancy terminology, algebraic expression. But that algebraic expression can be replaced with the word number or even variable. Okay? So let's read this again. The greatest common factor, or the GCF, is the largest number or variable that divides two or more terms. Okay, so right away we have to understand that we're going to be looking at two or more terms and then asking what do they have in common and what is the largest number or variable that divides into those two or more terms that we're going to be examining. Okay, so let's jump into the first example. You're going to see some problems that say identify the GCF or identify the greatest common factor of 30 and 45, right? We're going to get two numbers here. And right away, we need to start breaking down these two numbers into their smaller components. What I mean by that is that if you think about the number 30, it's kind of a large number, and usually we think of large numbers as being made up of smaller ones. In this case, we want to think about all of the numbers, all of the pairs of numbers that multiply to give you 30. So we can break down 30 and look at all of its factor pairs by simply creating a t-chart and then systematically asking ourselves what two numbers multiply to make 30, where we'll put one number on the left side of the t-chart and one number on the right side of the t-chart. Okay. So right away, you always want to start these factor t-charts with 1 times that number, because 1 times that number will always give you the original number that we're examining, okay? So what we can do if we're not sure if that's correct, you can always just check yourself with a calculator. You can use a TI-84, a TI-30XS, or just any other calculator that you have on hand, and just check for yourself 1 times 30. Sure enough, that's 30. Okay. So the next thing we could do is, if you happen to have your times tables memorized, you might remember that 2 times 15 equals 30. And we could double check in the calculator if we needed to, 2 times 15. Okay. But at some point, for some of these numbers, you might start to think, oh, I'm a little bit rusty on my times tables. Maybe I'm forgetting something, or maybe I don't want to miss something. So one strategy that you can take is think about it this way. Instead of thinking about pairs of numbers that multiply to make this number, we could think about the main number, 30 in this case, divided by what yields a whole number. So think about this. 30 divided by 1 is 30. 30 divided by 2 is 15. So we can just count up and progressively divide 30 by a larger and larger number and see if those give us another whole number, okay? We don't want to deal with decimals here or fractions, so we'll try 30 divided by 3. That's 10. So I'll put 3 times 10 is 30. And then we might try 30 divided by 4, and notice that we have a decimal answer, 7.5. That's not going to work. We want to keep only whole numbers, okay? So we might move on to 30 divided by 5. and we get 6. 5 times 6 is 30. And then finally, we might do 30 divided by 6, which is the next number up. But there we get 6 times 5, right, would give us 30. So once we start repeating ourselves, we already have the pair 5 times 6. Once we start repeating ourselves, even though it's switched around, we have 6 times 5, we can stop. We don't want to have any repetitions there. We just want all of the unique factor pairs that will make 30. And so we have 1, 2, 3, 4 different pairs of numbers that multiply to make 30. Okay. And again, these are all factors of 30. 1, 2, 3, 5, 30, 15, 10, and 6, they're all factors of 30. Okay. So we wanted to start by breaking down each of the numbers that we're examining, 30 and 45, using this factor T chart. So we're going to speed up a little bit and do a factor T chart for 40. I'm sorry, for 45 rather. Okay. So we're going to start the same way. We might know that 1 times 45 is 45. And then we might get a little bit fuzzy with our times table. So if you have a calculator handy, you can just grab that calculator and see 45 divided by 2. Do we get a whole number? No. Okay. So we'll do 45 divided by 3. So that says 3 times 15 should give us 45. Okay. Then we can move on to 45 divided by 4. That didn't work. 45 divided by 5. That's 9. So that's 5 times 9. 45 divided by 6. 45 divided by 7. 45 divided by 8. None of those worked. And then 45 divided by 9, well, guess what? That's 5. But we already have 9 times 5. Okay, so we can stop there. So these 1, 3, 5, 45, 15, and 9, these are all factors of 45. Okay. Now, since we have all of the factors of 30 and all of the factors of 45, we want to remind ourselves what it is we're looking for. We are trying to identify the GCF, the greatest common factor of 30 and 45. So what is the largest number or the largest factor that both of these two numbers have in common? So we might look through the T-charts here and say to ourselves, well, they both have a 1 in common. They don't have a 2 in common. They do have a 3 in common, so that's a common factor. They have a 5 in common. And we can continue on and say, okay, we don't have a 6 or a 9 in common. We don't have a 10 in common, but we do have a 15 in common. Okay. So of all the common factors, it looks like 15 is the largest factor that they have in common. And so for this problem, that will answer our question. The GCF that we're looking for here is simply 15. It's the largest number that divides into 30, and it also divides into 45. Okay. So as we progress through these problems, we're going to pick up a little bit of speed. So here we go into the next problem. Identify the GCF of 3x squared, 6x to the 5th power, 21x to the 4th power. Okay. So what I recommend is making a factor T chart for these variable terms. And even though they're variable terms, we can still do T charts at least for their coefficients. So this one has a coefficient of 3. 3 happens to be a prime number. So we're just going to say that 3 is 1 times 3. And then 2 doesn't divide into 3. And then we're back at 3. Okay, so this is a very small factor T chart here. We'll look at 6, x to the 5th. And notice that we're sort of ignoring the variables at this moment, but it'll come back into play in a second. So we have 1 times 6. That'll give us 6. And then 2 times 3. Okay. the next one would be 3 times 2, but since we already have that, we can go ahead and move on to the next term. So the next term is 21 x to the fourth. Okay, and 21 is 1 times 21. If you really need to check, 21 divided by 2 does not work. Okay, 21 divided by 3 is 7. So 3 times 7. And then you could go through the whole list. 21 divided by 4 doesn't work. 21 divided by 5 also doesn't work. 21 divided by 6 doesn't work. And then you're back at 7, so we can stop there. Okay, so right away, we want to look at these factors for each of these terms, at least their numeric parts, and say, what do they have in common? What is the largest number that they all have in common? And right away, we can probably see that each of these t-charts has a 3 in common, and that is the largest number that they have in common, right? Again, just to clarify, even though 6 is a factor of this term, and it's larger than 3, none of the other t-charts have a 6. Okay, so it has to be common among your 3 terms. Otherwise, you can't use it as the GCF, okay? Now, since we found the numeric part of this GCF, you might think that we're done, but we're not done quite yet. You have to remember what these exponents mean, okay? So these exponents, x to the second power, means that you have x times x, right? You have 2 copies of x. In other words, these are 2 factors of x, okay? For x to the 5th power, you have x, 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 and that means that this term has 5 copies or 5 factors of x. And I've kind of run out of space over here, but if you think about this exponent and extend that logic, x to the 4th power has 4 factors of x, okay? So think about what is the most number or the most copies of x that each of these 3 terms has in common. Another way of thinking about it is if you were to take some number of x's away from each of these terms, how many can you take from each without going over, right? So like this term has 2 x's. So I could take both of those. That would be the most x's that I could take from that term. This term has 5 x's. So I could take 2 x's from there, and that would be fine because I wouldn't go over. I could also say I have 4 x's here, so I could also take 2 from that one, and that would be fine. And so we could take 2 x's out of each of these 3 terms. But for a moment, you might confuse yourself and think, well, x to the 5th power is the biggest exponent here. Why can't I take x to the 5th power? Well, certainly I could take all 5 of these x's, right? But the greatest common factor means that I need to be able to take that number of x's or that many factors out of each of these terms. So if I go to this first term and try to take 5 x's away from here, there's not 5 x's to take. I cannot take 5 x's from there. I can only take 2. Okay, so the most number of x's that you can take from each of these 3 terms is 2. And so the GCF is going to be that numeric part, which is a 3, and then x to the 2nd power. The GCF here will be 3x squared. Okay. You'll eventually get to some problems that ask you to identify the GCF. And these 2 terms that you're comparing look kind of intimidating, right? We have 2 times x minus 5 and 7 times x minus 5. And here, we really have to go back to the definition of greatest common factor to understand what's going on. The definition is the GCF is the largest algebraic expression that divides 2 or more terms. So think about it as the largest algebraic expression. It could be a number, it could be a variable, or it could be something in parentheses that both of those terms or all of those terms have in common. Okay. So if I'm just glancing at these two terms, I might say to myself, well, they both have this x minus 5, this big old chunk of information in the parentheses. That's the same between these two terms. So what you might say to yourself is that the GCF of those two terms is the polynomial x minus 5, or the algebraic expression x minus 5. We call this a binomial factor, where binomial means that there are two terms that we pulled out of each of these original terms that we were looking at. Right? In the parentheses, there are two things there. And so the GCF, the thing that both of those terms had in common, was x minus 5. Okay. Okay. So you might have to sit with that for a little bit. But once you start practicing identifying the GCF, then we can actually talk about factoring out the GCF from a polynomial expression. Okay. So when we talk about factoring can sometimes mean rewriting an expression so that it's not in terms of addition and subtraction, but instead it's written in terms of multiplication. So factoring, you can think of it as writing an expression in terms of multiplication. So right now, if we look at this first problem, we have 4t plus 8. Those are not like terms because we do not have two variable terms. So we can't combine like terms, even though that might be something that really pops out at you, okay? We have to understand what we're doing or what is meant by factor, okay? So the way you're going to start this off is that first, you want to identify the greatest common factor between these two terms. So we have 4t and we have 8. 4t and 8. And then you might want to make t-charts for each of those terms, right? So 4t, we know it has a factor of t, and we also know that 4 can be written as 1 times 4 and 2 times 2. We know that 8 can be written as 1 times 8, 2 times 4. 3 doesn't divide into 8, and then we're back at 4. So there we go. We have our two t-charts. The greatest common factor between those two terms is 4. So since that's all they have in common, what we next need to do is write the GCF, then divide out the GCF from the original terms, okay? So we're going to take this expression that we have here, and we're going to rewrite it first by writing down the GCF, which is 4. And then we want to write our expression in terms of multiplication, so I'm going to open up a set of parentheses. Okay. And then I want to divide the GCF out of the two original terms. So think about it this way. If I had 4t and I divided this by 4, I have 4t divided by 4. Well, the 4's will cancel out because 4 divided by 4 is 1. So what I'll have left over, since 4 divided by 4 is 1, I'll have 1t, or simply t. Okay. And then I'll take my GCF and I'll divide it out of this term over here, the 8. So I had plus 8. So positive 8 divided by 4. 8 divided by 4 is positive 2. Okay. So that's pretty much it. It might seem anticlimactic, but the answer that you're going to enter into ALEKS when you're working on your homework is 4 times t plus 2. And that is factored form. Okay? So in reality, we only have 2, maybe 3 steps that we're really looking at. You have to be able to identify the GCF, and then you have to be able to divide it out of each of the terms that you have there. Okay? So let's do it really quickly for number 2. Let's identify the GCF. So first, the GCF here, you might look at negative 12 p to the 4th, and then just focus on breaking down the negative 12. I'm just going to focus on 12 and break that down into 1 times 12, 2 times 6, 3 times 4. Okay. We also have negative 14p to the 3rd power. That's going to break down into 1 times 14, 2 times 7, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, and then we're back at 7. And then we have 18p squared. So we have 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and then we're back at 6. So right away, we can maybe identify that, let's see, the biggest number that all of these have in common. I wanted to say 6 because these two had a 6, but we don't have a 6 in this middle t-chart. So we have to go smaller than that. 4 is not going to work. 3 is not going to work. So it looks like 2 is the greatest common factor there. So we'll put it 2. And then let's look at the variables. So this has 4 p's. This has 3 p's. This has 2 p's, right? P to the 2nd power. So the most p's that I could take out of all 3 of them that they share is p to the 2nd power. Okay. So once you identify that GCF, we'll go ahead and write that GCF down. We have 2p squared. And then since we're trying to rewrite this expression in terms of multiplication, we'll open up a set of parentheses, and then we'll divide this GCF out of each of these 3 terms. So we'll have negative 12p to the 4th power divided by 2p squared. Okay. So negative 12 divided by 2 is negative 6. And if we had p to the 4th power and divided that by p to the 2nd power, think of that like we have 4 p's here, and then we took away 2 of them. So that means we have p to the 2nd power left over. And that's it. We can move on to the next term. Divide that by 2p to the 2nd power divided by the GCF. So negative 14 divided by 2 is negative 7. P to the 3rd power, you have 3 p's here. And we're dividing that by p squared. So we're dividing out or taking away 2 of those p's. So 3 take away 2 is going to be p to the 1 power, but we don't have to show that 1 power. Okay. Divide this 18 by 2p squared. And then we know that 18 divided by 2 should give us a positive 9. And then p squared divided by p squared, think of that like I had 2 p's here, and I divided out 2 of those factors of p, so there's no p's left. I'm not going to put a p down. Okay, so your final answer for this one should be written as 2p squared, the GCF that we factored out, minus 2p squared times negative p to the 2nd power minus 7p plus 9, and that is factored. Okay. Finally, we have a set of terms that look kind of complicated. Okay. But if you recall, on that last example that we looked at when we were just identifying the GCF, sometimes your greatest common factor is a algebraic expression or a binomial factor. So if you look at these 2 terms, you can quickly identify, oh, they have this y plus 3 in common. Okay? So if these terms have y plus 3 in common, then we can say the GCF here is equal to y plus 3. Okay? So we're going to follow the same steps that we did for the previous 2 problems. we're going to write that GCF, which is y plus 3 in parentheses. And then since we're trying to rewrite this expression in terms of multiplication, we'll open up another set of parentheses. Now we need to figure out what goes into the blank. Okay. So just as we did with the previous problems, we will take the GCF and divide it out of the original two terms. So we'll take 7x times y plus 3 and then divide out the y plus 3. Well, if this looks really complicated to you, just think about it this way. Y plus 3 is just a number, right? And anytime you have a number divided by itself, we often say that that cancels out, or that cancels out to 1. So what we can do is just say, oh, these guys cancel out, so what's left over? Well, what's left over is just the 7x. So I'm just going to bring down the 7x. So even though that GCF is kind of intimidating, if we know some really slick tips and tricks here, that any number divided by itself is going to be 1, or any number divided by itself cancels out, we can just cross those out and then bring down the remainder. Okay, so we'll move on to the next term. Here we have negative 9 times y plus 3, and we're going to divide out that GCF y plus 3. Okay, so again here, if you have something divided by itself, even if that something is complicated looking, y plus 3 divided by itself cancels out to 1, so we can cross those out, and we bring down the negative 9. And that's it. So our factored form of the original problem is y plus 3 times 7x minus 9. Okay, so if you need to pause the video, you can pause the video here, let that sink in. But you have to understand how to factor out the GCF in order to understand the next factoring technique, which is factoring by grouping. Okay, and the reason why I say that is because factoring by grouping is in some ways just repeatedly factoring out the GCF. One important note that you have to realize is that you can only use this technique whenever you have a 4-term polynomial. Okay, so for this class, you'll never use it for anything besides those 4-term polynomials. So it makes a lot of sense to count how many terms you have before you jump right in. Okay, so we have 1 term, 2 terms, 3 terms, 4 terms. So this is a really good candidate for factoring by grouping. Okay, and I think that this is the kind of thing that is easy to learn by doing. So just follow along and see if this will make sense to you. So long as factoring out the GCF makes sense, this should be not too painful. Okay, so first of all, we have 4 terms. Let's go ahead and sort of divide and conquer and look at the first 2 terms on their own. And if you need to, you can cover up those last 2 terms. So let's simplify our lives a little bit and think about these 2 terms. What is their greatest common factor? Well, we have an x here. We have negative 5x squared. Well, it doesn't look like they have a numeric factor in common besides 1, but they do have a variable in common. They both have x squared in common, right? 2 x's is the most I can take out of both of those. So I'll write 2x, and I'll just proceed with factoring out the GCF, where I open up a set of parentheses, and then I can divide out x squared from each of those terms. So if I take x squared and divide it out of x to the 3rd power, I should have x left over. And then if I have negative 5x squared divided by x squared, well, the x squares, they're the same. So those guys will cancel out, and all I'm left with is negative 5. Okay, so maybe take a moment to let that sink in. And this is called factoring by grouping because we're grouping the first 2 terms together, factoring out their GCF. And then we're going to sort of ignore the first 2 terms and look at the last 2 terms and identify their GCF. Okay, So right away, I know that, the numbers that divide into 4, the largest one is 4 itself. Okay. So I can ask myself, does 4 also divide into 20? Well, yeah, that'll work out. Okay. If not, I can go ahead and draw some t-charts over to the side, but just for simplicity's sake, I'll leave that to you guys. So the GCF here between these two terms is going to be a 4. So we're going to bring this plus 4 down. Okay. And then we're going to open up some parentheses. Okay. And then you ask yourself, well, what do I need to do with this GCF? Well, I need to divide it out of each of these two terms. So 4x divided by 4, the 4's will cancel out. What am I left with? X. Negative 20 divided by 4 is negative 5. Okay. And now that I've done that, I factor out the GCF from these two terms. I factor out the GCF from the first two terms. I have this somewhat more complicated looking polynomial, but there's something really nice about this polynomial. I'm going to go ahead and just make this blue so that you can see it maybe a little bit more clearly. What do these two polynomials have in common, or what do these two terms have in common? Well, this binomial in parentheses is exactly the same. So guess what? This now becomes the GCF, the x minus 5. So I'm going to write x minus 5 as my GCF. I'm going to pull that out or factor that out to the front of this expression. And then I will open up another set of parentheses to see what's left over. So if this is the GCF and I divide it out of this term, these guys cancel out. And what's left over is just the x to the second power. So now I'm going to take that GCF and divide it out of this set of terms, x minus 5, divided by itself. Hey, guess what? That cancels out yet again. What's left over is plus 4. So that's what goes into the parentheses over here. Okay. And that's it. Kind of anticlimactic, but in reality, you might notice that factoring by grouping is simply applying factoring out the GCF 3 times, right? We factor out the GCF from these two terms, factor out the GCF from those two terms, and then we looked at what we had and said, oh, those things in parentheses, they're exactly the same. So we can factor that out one more time as the GCF, and then whatever was left over, the x squared and the plus 4 in this case, we throw them into their own set of parentheses here, and then that will complete the factoring by grouping process. Okay. So let's take a look at another one, and this will be the last problem that we do here in this lecture video. Let's look at the first two terms. What is the largest number that divides into 20 and negative 25? And right away I'm thinking, okay, the largest number that divides into 20 and 25 is 5. But I have to ask myself, do these two terms have a variable in common? This one has 2 x's. This one has an x and a y. So they definitely both have an x in common. Okay. So once I identify the GCF, I can open up some parentheses and then divide that GCF out of each of these terms. Okay. So 20 divided by 5 is 4. X squared divided by x is x. Negative 25 divided by 5 is negative 5. And then the x's here will cancel out. So I'm just left with this y. I'll move over to the next two terms. And I'll ask myself, what is the GCF of those two terms? So 24 and negative 30. What's the largest number that divides into both? Well, you can make a factor t-chart if you need to for 24 and 30. I'll leave that to you guys. But it turns out that it is 6. Okay. So 6 is a large number that will divide into 24, and it also divides into 30. So I'm going to bring down the plus sign. I'm going to say we have a 6 in common as far as our factors are concerned. And then do we have a variable in common? Well, this one has an x and a y, but this actually. So do they have a y in common? They have one y in common. So once I identify that as the GCF, I can open up some parentheses, and then I'll divide this GCF out of these two terms. So 6y is what we're dividing by over here. And then 24 divided by 6 is going to be 4. And then there's nothing to cancel out the x, but we can cancel out this y because y divided by y, that'll cancel. We'll just bring the x down. Okay. If you need to see that crossed out, cross that out. Okay. Negative 30 divided by 6 is going to be a negative 5. And then y squared divided by y is going to be y. Okay. And it's really important to realize at this point, if the stuff in parentheses, these binomial terms, okay, if that's not the exact same, 4x minus 5y, 4x minus 5y, if it's not the exact same numbers, the exact same variables, the exact same symbol, mathematical operation between them, then you've made a mistake. Then you need to go back because you haven't factored out the GCF completely. But if these guys are exactly the same, then that now becomes the new GCF. So we're going to put 4x minus 5y in the front. And then we can say, oh, if we're dividing 4x minus 5y out of here, we should have 5x left over. And if we're dividing 4x minus 5y out of this term, then we should have this positive 6y left over. And so this expression is now written not in terms of subtraction and addition, but in terms of multiplication. Since we have parentheses and parentheses, we have this times that. This is factored. Okay. And that's it. That's the process. Okay. So I'll be making another video for the last two factoring methods, that is factoring trinomials using the AC method and our special factoring formula, which is called the difference of squares factorization. So look forward to that, and I will see you guys later.